So in this recording, we will look through quicksort algorithm, which is also a divide and conquer algorithm similar to merge sort. And some notes before we move on is that in quicksort we have a notation like a pivot, like a concept of pivot element, and it can be chosen in different ways. For example, here we can pick it randomly among the indexes of our array, but in our algorithms we will just pick the first element of the array as a pivot element. And also one more thing is that the essence of the algorithm is that we want to store all the elements that are smaller than the pivot element on the left hand side, and all the elements that are bigger than pivot on the right hand side of the array. And in such a way we can reach to the sorted result. So this algorithm consists of like two parts, which is a QS. This is the main algorithm, and the partition is also the main part of it. It basically does the most job. Also, similarly to previous video recordings, we will have this example on paper and also the code implemented in Python. So let's go to the so yeah, basically this is the code, and there's no big difference from the structogram. And here we have the example, which was quite easy to do. I mean, there were not special cases included, but we will see. So, as I said, I just indicated here that all elements on indexes I should be smaller than pivot, and everything else should be like J indexes should be greater than pivot. So this is the given input, and the first thing to do is we take out the first element from the array as a pivot, and we will save it in variable x. After that, we take the last element of the array and put it into the first index. So in our example, by chance, both the last and the first elements are 4, so it might not be clearly seen, but this 4 is removed to this x, and this 4 is put back into this first index. And then we will have these two indexes, I and j, and we start I from the first element. And we need to compare i's element with the pivot, and if it is less or equal to pivot, then we need to increase I. Otherwise, we need to stop this loop. So 4 is equal to 4, which is a pivot. So we go to the next element, which is 3, and 3 is less than 4. So we go to 6, and 6 is not smaller than pivot anymore. So we stop I here, and we start j, which is where j is equal to I plus 1. And j should go as long as it is its element is bigger than pivot. And as you see, 2 is not greater than 4, so j immediately stops. And when we have these fixed elements in indices I and j, then we need to swap them. So 2 comes here and 6 comes instead of 2. And we increase both I and j. So I will be here in the next iteration and j will be here. So i's element is bigger than 4, so I will immediately stop. And we continue with j, and j's element is 9, and 9 is bigger than 4, so we go to 8, and 8 is also bigger, and we go to the next element, but the next place is empty, so we stop. So as I said earlier, everything that is on the left hand side of pivot should be less, and on the right hand side should be smaller. And for this reason, when we reach the end of the array, then what we need to do is we need to swap, not like swap, but we need to put pivot element instead of i's element, and we need to put i's element to the end of the array. And as you see here, we put 4 here and 6 here. And one more thing is that you need to, just for readability, or for, I don't know, understand, just to understand it better, we need to put this plus sign to the pivot element. So this is the end of the first partition. The next thing is we need to do the same partitioning on the subarrays on the left hand side of the pivot and on the right hand side of the pivot. And the idea is the same, so we do the same thing, and we pick the pivot element here, we move the last element to the first place, and we start I index, and we see that 2, 3 are both smaller than 4, and we reach the end of the array, and then we just need to put the pivot back to the empty place. And this is already sorted, and we do the same thing on the second subarray, and here is the situation. It's exactly the same, and here we have sorted subarray, and when we put them back to this, then we will get the sorted array. That's all, and this is the code. Here we are picking the pivot element randomly, but you can pick it as the first element of the array, last element, or certain index, depends on your implementation.